I've mentioned Service Container a few times already, so let's actually dive into it to understand what it is and how it works in Laravel. Simply put, Service Container is your IOC or DI container. It's basically the dependency injection container, and if you took my PHP course, then you will remember we covered this in there and even implemented a very simplified version of it. If not, or if you don't remember, dependency injection is a technique or a pattern where an object or a class receives its dependencies from an external source rather than creating those dependencies itself. This helps to decouple your code, making it more modular and easier to test. The service container is essentially a tool for managing those class dependencies. Let's look at this controller as an example. So I have this transaction controller in here that we've created previously, and we have a few methods here. Let's look at this show method that accepts transaction ID as an argument. So transaction ID is our dependency. Now this is not a class dependency, this is not an object, it's an integer. But if we accepted another dependency here, like a transaction service class that maybe handled some transaction processing or transaction lookup from database table or something like that, that would be our class dependency. In that case, you may want to inject that transaction service object into the show method or into a constructor and then access it within the methods that it would need to have access to that transaction service class. So let's create a constructor here and let's accept the transaction service class in here. So we're going to have private read-only transaction service, and we don't have this class yet, and we'll create that in a bit. But this basically is the dependency injection. We are not instantiating or creating this class or this object within the controller. Instead, we're accepting this as a dependency. The benefit of this is that it makes writing tests easier because we could create a mock version of this transaction service class and pass that in place of the actual transaction service class. Moreover, this specific class, in this case controller, as I mentioned, is not responsible for creating an object or an instance of the transaction service class. It doesn't care how that object is created. It just takes that as a dependency and shifts that responsibility elsewhere. So what's happening here is that we are inverting the control, hence why dependency injection is usually referred to as a specific form of inversion of control, also known as IOC. Inversion of control is a design principle that shifts the control from the custom code to an external entity or an external source that is often referred to as a framework. This principle allows the framework or that external entity to manage the execution and configuration of custom code, which leads to more modular and decoupled code. In this context, the framework refers to any generic code that manages the lifecycle and dependencies of components, and it's not necessarily referring to the Laravel framework per se. So that's sort of like the formal definition of the IOC. And the dependency injection is just a form of inversion of control or a technique to implement the inversion of control. In that case, the control of object creation and their dependencies is basically inverted. So instead of objects creating their own dependencies, the responsibility is transferred to an external source. In this case, that external source can be something else that instantiates this controller or even something outside of that. This specific controller does not care where or how this transaction service class is instantiated and passed down. There are different types of dependency injections. The one shown here is called construction injection, where dependencies are provided through the class constructor. You could also have a setter injection where dependencies are provided through setter methods, and a method injection where dependencies are provided directly to the methods that need them. So as I mentioned before, if we injected the transaction service directly into the show method, that would be the method injection. In fact, if we scroll down a little bit here, this is another example of method injection. The store method does not care how the request class is instantiated, it just expects a proper request object to be passed down to this method. And Laravel basically handles that dependency injection and resolves these dependencies from the container on its own. We could, as I mentioned, add the transaction service here as another dependency, and this would work as well. Now, these type of injections don't only apply to controllers. We could have the constructor or method injections in other classes as well. We could have it within our transaction service class if we had other dependencies within the transaction service class. Now, the way these dependencies are resolved and passed down to constructors and the methods is a different story. Typically, it's done by using IOC or DI containers and auto-wiring magic. The container is essentially responsible for managing and injecting dependencies wherever they're needed. It's kind of like a registry, a tool that helps us manage dependencies and dependency injections. Laravel Service Container is basically just that, but on steroids. As you noticed, we did not pass the dependencies to the constructor or the store method in here. They are automatically resolved and injected by the framework. Let's in fact create this class so that I can show that to you. So we'll create it within the services directory. Let's actually move it out of the HTTP. So it will be app services. Let's create that. And we're just going to have a single method here called find transaction, and we'll accept the transaction ID. And for now, we're just going to return some kind of array containing the transaction with that ID. Of course, this is just an example. It would be completely different in an actual practical example, but that is beyond the scope of this lesson, and it doesn't really matter. So we're just going to have some kind of amount, maybe 25, and the transaction ID, and that's good enough for now. So let's add that array as a return type here. Let's go back, and in the show method, we're going to get the transaction. So we'll do this transaction service, find transaction by the ID, and we're going to return transaction ID as well as the amount. So we'll do transaction amount. And let's also remove this dependency from here since we have it in the constructor. So let's test this out to make sure that it works. Let's go to the browser. We'll go to transactions 1, 2, 3, and sure enough, that works. We see the 1, 2, 3, which is the ID, and 25 is the amount that we hard-coded in the return value. So as you noticed, we did not have to create a new instance of this transaction service class. It was sort of automatically resolved and injected by the framework. That is because Laravel has something called zero configuration resolution, which is basically auto-wiring. It uses PHP's reflection API to inspect the class dependencies by looking at constructor parameters. If class has no dependencies or only depends on other concrete classes, then the container will automatically resolve or create an instance of that class. And it does that recursively, so if your class has other concrete class dependencies, then it looks at that class's dependencies and so on. So it sort of goes recursively and resolves all those dependencies. And by the concrete class, what I mean is that it's a class that can be instantiated that is not an interface or an abstract class. Otherwise, you'd get some kind of exception. So if transaction service was like an interface, you would get an error stating that target class transaction service is not instantiable. We can actually see that in action. So if we make this into an interface or an abstract class, it would not work. So if we change this to an interface and open the browser, refresh the page, we see that we're getting this exception that target transaction service class is not instantiable. And the same would apply if this was an abstract class. So if we change this to abstract and refresh the page here, we get the same exception. But if it's a concrete class, then it works as expected. So this means that you don't need to instruct the container how to resolve these concrete classes. You don't need to add entries in configuration files, set up bindings, and so on. You would, however, set up bindings if it were abstract class or an interface, but for concrete classes like this, you don't need to set that up, unless of course you want to and have a specific use case. In addition to that, Laravel will automatically inject and resolve dependencies using the service container in other parts of the framework, like within the controller methods that we saw in here. This gets automatically injected here, or we could inject other services in any of these methods and it would work as well. For example, add that transaction service here, and instead of using the one from the constructor, let's use the one from here. Let's open the browser, refresh the page, and as you can see, it works as expected. And in addition to Laravel automatically resolving these dependencies from the constructor and the methods in the controller classes, it can also do the same thing in other types of classes, like the handle methods of your jobs, the middlewares, and so on. So that means that in a lot of the cases, you won't even need to interact with the container directly to bind or resolve anything. That being said though, there are times when you would want to instruct container how to resolve certain classes. As I mentioned before, what if you were injecting a non-concrete class like an interface here? What if this was an interface? Framework by default won't know which concrete implementation of the said interface you need, so in that case, you would have to tell the container that, hey, whenever you're told to resolve an instance of this interface or an abstract class, you can give them this concrete implementation of it. And we can do that from the register methods of the service providers. And we'll talk about the service providers a bit later, but for now, I just want to show you an example of how we can bind things into the container. So let's create an interface, maybe a payment processor, and then we may have multiple payment processors like Stripe and PayPal or something like that. Having an interface here allows us to easily swap out the concrete implementations while not affecting the underlying code. And maybe we'll define a single method here called public function process, and it accepts a transaction. So let's say array transaction. And for now, we can set the return type as void. Now, we of course going to get this error if we refresh the page because payment processor is an interface and it is not instantiable. To bind this to a specific concrete implementation, we need to open the service provider and bind that in the container. So we'll open app service provider, and within the register method here, we can call the bind method on the app instance, and the app object is accessible from within the service provider because as you can see, the service provider extends the base service provider, and this here has access to protected app or application object. So we'll do app bind, and we'll bind the payment processor interface to a specific concrete implementation of this payment processor. And let's say we have Stripe as the processor, so we'll do it this way. And now what we're doing is that we're instructing Laravel that, hey, whenever someone requests payment processor class, when you're trying to resolve the payment processor class, which is an interface, give them an instance of Stripe instead. So let's create this concrete class. We'll create it within maybe app services for now. And we are going to make this implement the payment processor. Let's add that method. And for now, we don't need to do anything with the process method because we're not actually implementing that. But this is going to work. Now, if we open the browser and refresh the page, we see that we no longer get that error. There are a bunch of other helpful methods available on the container instance. You can bind single instance using singleton, which essentially just resolves the class only one time and then uses that same object afterwards if it's asked to be resolved again. You can do contextual binding, bind primitive values, you can extend bindings, and so on. You can check the documentation for all kinds of bindings depending on your needs, but this specific binding is a very simple binding. And if this is all we need to do, there is an easier way to do this instead of calling the bind method. And that is by defining the bindings property. So we can do bindings property here and put the payment processor as the key and the Stripe as the value. So we'll do payment processor class and then Stripe class, and we can comment this out, and this is going to work as well. So if we go here and refresh the page, we're not getting error. That means that the payment processor is being injected into the transaction controller successfully. Now, in some cases, you may not always have these simple bindings. You may want to pass some things down to Stripe's constructor, maybe configuration information or API key or token or something like that. So in that case, instead of binding it this way, we could use a closure on the bind method. So let's get rid of it from here. And then instead of binding it to a specific class, as you can see as another type of argument, it accepts closure in addition to string. So we can do function, and then in here, we can simply return a new instance of Stripe, and this will still work the same way. But now we have control on what we're passing to the Stripe as a dependency. Maybe we had a constructor here that accepted the credentials or configuration or something like that. So let's say we had config, and this we're going to set it to be private read-only. We can actually make the class read-only itself, and then we could simply dump the config here. So let's go back here, and we're going to pass some configuration. For now, I'm just going to pass an empty array, but if we open the browser, refresh the page, we see that it works. Now, what if your Stripe class had other dependencies in addition to just regular non-class dependencies? Maybe we had some other dependency here, something like sales tax calculator or something like that. So maybe we had private sales tax calculator. And of course, if we refresh the page, this would fail because we need this object and we're not passing it in here. So we are sort of forced to instantiate that as well. So we would have to do new sales tax calculator, and we would need to create this class as well. So let's create that within the services as well for now, and then this will work. But as you can tell, this can become complicated, because what if the sales tax calculator has its own dependencies, its own class dependencies, that it would have to instantiate those as well, and so on. So the solution here is basically to resolve the sales tax calculator from the container. The good news is that this closure actually gets the application instance passed down to it as an argument. So we can accept the application in here, and then we could resolve this from the application ourselves. Because remember, the application class is in itself the service container. So if we open the application class here and scroll up, we see that it extends the container. So that basically is our service container. And we could call a method called make, which essentially resolves and creates the new object of the class. So instead of doing it this way, we could do app make sales tax calculator class, and this is going to work the same way. So if we go back here, refresh, it still works. And now if sales tax calculator had other class dependencies, it would work as well. Now you might be asking, why can't we call the make method on the Stripe? And the answer to that is we can. So let's refactor this a little bit. So we'll do app make, and this way we don't have to create the instance of sales tax calculator. The service container should take care of that on its own. Now let's refresh the page, and we're getting an error. And what this error is telling us is that the Stripe class has a dependency that is not resolvable. What that means basically is that we are expecting an array config. It's not a class, and the container doesn't know how to instantiate or resolve this class. Because remember, we were passing that empty array into the stripes constructor, and now we are just telling Laravel to instantiate the stripe class, and it doesn't know how to do that because it doesn't know what to pass for this config. It is able to resolve this properly, but it doesn't know what to do with this config parameter. So to fix this, if we inspect the make method, let me actually type in this. So we'll do application from the eliminate contracts foundation. If we inspect the make method, we see that it accepts as the second argument parameters. So that means that we can pass list of key value pairs of the parameters that the stripe class accepts. So we can do config equals an empty array, and now this should work. So if we go back to the browser, refresh the page, we see that it works. Now, in some cases, you may not have access to the application object directly like we do in here. Maybe you need to resolve a class somewhere else in your application. In that case, you could use the app facade or the app helper function to get the application instance. So like in controller, for example, the Laravel automatically resolves the constructor dependencies as well as the method dependency injection, right? But what if you wanted to resolve a dependency from somewhere else, or maybe even from here, but not inject it for whatever reason? In that case, you would use the app facade or the app helper. So if we inspect the app helper function, this basically just returns the instance of the container, which is our application instance. And if we do the app make, this essentially does the same thing. So we can do app make payment processor, and this should work the same way. So let's do dump this way. Let's open the page and let's go to transactions, hit enter, and sure enough, that works. So we're getting this twice because we're dumping that configuration in the stripe in here, and we're instantiating this twice. And actually, this would be a good example to show you the singleton version of this. So the reason we're getting dump twice here is because we are instantiating the stripe one time when injecting it here, and then we're resolving it ourselves again within the index method. And that's why it's basically printing it twice. Now, if we go to App Service Provider and change this to singleton, now it's going to print it one time. So pay attention to these two arrays. Let's refresh page, and sure enough, now we have single array. That means that we're getting the same object of the stripe class regardless of how many times we resolve it from the container. Alright, the other thing that I wanted to show you is the app facade. So you could do app facade make, and this will work the same way. Let me import this. Let's open the browser, refresh the page, it works. Another way you could resolve the class is by simply using the resolve helper function, and this will work the same way. So let's refresh, and it works. And if we inspect the resolve function, we see that it simply calls app helper function. And notice that the app helper function doesn't call the make method on it, because if we inspect the app helper function, if we pass a class name here, then Laravel will basically call the make method for us. So it's kind of like a shortcut. So either you can do the app make, or you can simply do app this way, and it's going to resolve for you. Refresh the page, and it still works. Now, in addition to this, another way you could resolve dependencies is by injecting the container instance into a constructor or into a method. So we could do something like private read-only container from the eliminate contracts container, and then we can do this container make, and this will do the same thing. So if we refresh the page, we see that it works. So as you can see, you have a lot of options and ways that you could resolve dependencies using Laravel's container. And in general, arguably, that's one of the great things of Laravel, where you have many options and ways of doing the same things. It lets you accomplish the same thing in multiple ways, so it fits multiple styles of programming. Alright, so now you know how to use Laravel Service Container and how it works on a high level. You can stop the video here and move on to the next episode if you want to, but if you want to dig a bit deeper and understand how this is done behind the scenes, then stick around because we're going to dissect it a little bit. If we open the application class here, so let's open application from the foundation, we see that it extends the container, as I've already mentioned that multiple times before. If we inspect this container class, we see that it implements the container contract, which basically is the container interface from the contracts directory. So let's inspect that. And we see that the container extends the container interface, which is from the PSR. And that's basically the PSR11 container interface. We covered PSR11 and basic implementation of this container interface in the PHP series, so check that out if you need a refresher on it. But as you might know, the container interface from the PSR11 only has two methods. It has the get and has. But Laravel's container interface has a lot more methods than just those two. Let's dig into the get method implementation to see how it works. So let's open the container implementation. Let's search for the get method here. And this is basically the implementation of the PSR11 get method. And we see that this get method calls the resolve method. And if we scroll up here, we can actually see the make method, which also calls the resolve method. So let's dig into the resolve method. The resolve method handles a bunch of logic here. It does the alias handling, it does abstract interface logic to get the concrete class, it has the singleton logic and so on. But for now, we're not interested in any of that. We're interested in where is that PHP's reflection API that makes all the magic happen. So we're going to dig into this build method right here. And I suggest you read through this resolve code and understand what it does. It's actually pretty straightforward and self-explanatory, and it's also very well documented. As you can see, this comment here is very self-explanatory, stating that it's ready to create a new instance of a concrete class that is registered for the binding. And it's going to do that recursively to resolve all of the nested dependencies until all of them have been resolved. And you can see that in here too. If it's buildable, it calls the build method. Otherwise, it calls the make method, which in turn calls the resolve method again. So let's dig into the build method here. Let's scroll down a little bit. We create the reflection class instance of the given concrete class here. It then checks if it's instantiable, gets the constructor, then it gets its parameters, resolves the dependencies, and passes those dependencies as arguments as it creates the new instance of the class right here. So now you understand how Laravel Service Container resolves the dependencies, but we're still not sure how these dependencies are passed to our controller as an example. How does that automatic injection work and where does that magic happen? In here, we understand how the class is resolved, how the new instance of the class is created with all of the dependencies resolved for it, but how the dependencies are passed to this controller in here. To understand that, we need to dig into how the controller is actually created. So to do that, let's actually go back all the way and let's trace application request lifecycle from the beginning. That way, I think we'll be able to understand how the controller is resolved itself, and that should help us answer the question on how these dependencies are resolved and passed to this controller. Now, this may sound boring, but it's important to know how this works in my opinion. So let's open the public index.php, that's our entry point. We're handling the requests using this handle request. So let's open that into the application object. So let's go here, search for handle request. Notice the use of container right here. We're resolving the kernel contract using the make method, and the contract has a binding somewhere that resolves the specific implementation. Let's continue. We can open up the HTTP kernel now. So HTTP kernel. Let's search for the handle method here. Now within this handle method, we know that we send request through the router, so let's click into that. And within this method, we see another container method usage, and that is instanced. Now the next step in this cycle is the dispatch to router. So let's click into the dispatch to router. Dispatch to router calls the dispatch on the router instance. So let's go into the dispatch. This one calls dispatch to route. So let's follow that. Dispatch to route then calls the run route, but we first call find route to actually get the route and then run that route. So let's go into the run route, and here we're running the route within the stack. So let's dig into that as well. And in here we have this run method on the route object. So let's dig into the run method on the route object. And I think we're getting close. We have the container and we're running the controller right here. So let's click into run controller method, which calls the dispatch method on the controller dispatcher. But before it does that, it is also calling the get controller method right here to get the controller instance. So that's where that controller instance is being created from. And if we inspect this getController method, we see the container usage right here. It is using the make method, which in turn calls the resolve method to resolve the controller class. So that is how controller's constructor dependencies get auto-injected by the framework, because it's using the service container to create the controller instance. It's not creating the controller instance manually. It's using the container to resolve it. So pretty much the same thing we were doing here. Like this, we are resolving the payment processor this way. That's how basically Laravel is resolving this controller. And when it does that, all these dependencies get automatically injected. All right, so now we understand how the constructor is handled. The next step is to understand how the controller method dependencies are injected and resolved. Because in here, we are able to inject the dependencies into the methods like here, and this works as well. And we need to understand how that works. So let's go back to the route. Let's scroll up in here. Let's go to the dispatch method. And here we have a method called resolve parameters. So as you can see, we're calling the method on the controller object and we're passing all the parameters as arguments. And the parameters are resolved using this method. So let's dig into the resolve parameters. Let's go into the resolve class method dependencies and then resolve method dependencies. And we actually are already seeing the reflection API right here. We are creating a new reflection method object right here. So let's go into here. So we see that it's selecting the parameters using the reflection API. It calls the transform dependency on each parameter, and that basically creates the instance based on this. So let's dig into the transform dependency. If we have a class dependency and it has no default value, we call the make method again on the container to resolve it. So this is how Laravel basically automatically resolves controllers, constructor, and method dependencies. And it has this kind of support and logic in other parts of the framework as well, which you will notice as you progress through the series. So as you can see, it's not too bad, right? Of course, we jumped around and skipped some of the other parts of the logic, but sometimes you don't need to understand every line of code to get the basic idea or the big picture of what's going on. Sometimes all you need is a will and a bit of time and some curiosity, and you will uncover a lot of hidden stuff in Laravel's code base, which will teach you on its own many things. Some things you may like, some things you may dislike, you may agree with some things, you may disagree with some things, and that is perfectly fine. You don't need to and you don't have to agree with everything. You find something you like the way Laravel does it, that's great, then you can do it the similar way. You find something you disagree with it and can do better, sure, that's also great. Do it on your own way. Laravel gives you the flexibility to do it either the framework way or your way. It is entirely up to you. Now, one other very cool feature offered by the service container is the ability to invoke methods and have its dependencies be auto-resolved. Let me close all of these things from here and let me show you an example of it. Let's say that maybe we have some kind of closure, right? Let's say within the show method, and this may not be the perfect example to store the closure in, probably shouldn't be inside the controller, but just for the sake of example, let's say that we have some kind of callback and we do some callback function and then we maybe return something or whatever. But let's say that we wanted to inject some kind of dependencies in here, right? Maybe we needed the payment processor in here, payment processor, payment processor. And then when we call this way, we would have to pass that payment processor in it, right? Now, when I mentioned that this was a bad example, is because we have the payment processor in the constructor here, so we could basically just pass that in manually, or we could use the container to resolve that payment processor and pass it. But we could also automatically have Laravel inject these things into the functions and methods like that, basically perform the method injection automatically without us having to manually provide it. And the way to do that is by not calling the function or method manually like this. Instead, we would use the run method on the container instance. So we could either do app call, where we can pass a callback like this, and this will work. So let's actually dump the payment processor in here as well. And let me get rid of this. Let's clean this up a little bit. Let's say we don't need this from here. Let's remove it. Let's remove this from here as well. Let's open the browser. Let's refresh the page. And sure enough, we're getting the some callback function printed in here. And we're also getting the instance of Stripe, which means that this is automatically being injected because we are using this call method on the container or the application instance. If we just called the callback on its own like this wouldn't work because we're not passing that dependency. This would of course fail. We would have to pass that and provide that dependency manually. Now, of course, we could also call the call on the container instance. So instead of the app facade, we could simply do this container call, and this would work the same way. So if we refresh the page, we see that it works. All right, and this doesn't only apply to callbacks, it actually applies to classes and class methods as well. This is essentially what Laravel uses to automatically do the method injections in some of the other parts of the framework, like the events or the jobs and so on. If you inspect this and see where this is used, you will see that it's used quite in a lot of places. So if you had like a method on a class that you wanted to invoke and have all the dependencies automatically injected, you would use the call method. For example, maybe we had within transaction service some kind of handle method, and this one had the payment processor as a dependency. Let's do dump payment processor, and you wanted to have this automatically be injected. You would, instead of calling the handle method manually here, instead of doing transaction service handle and passing that dependency manually, you would do this container call and pass an array that contains the object as the first element and the method as the second element. So we'll do transaction service and then handle, and this should work as expected. So if we go here and refresh the page, we see that it works as expected. So as you can see, Laravel Service Container is a very powerful thing, and there are many other things that you can do with it. I just don't have a lot of time to cover everything in here, so I would suggest for you to check the documentation to learn what are some of the other things that you can do with Laravel Service Container. For example, you can do things like aliases. You can bind an alias like a string or a text to an implementation or a concrete class, and then you can resolve that from the container using the string text instead of a class name. You can also do things like contextual binding, where you can set up rules like if the payment processor is injected into the transaction controller class, resolve it using Stripe, otherwise resolve it using another implementation, and so on. You can also bind some primitive values if you wanted. And one of the other very powerful features of the container is that you're able to swap any of the Laravel's implementations with your own implementation. So it gives you a lot of flexibility that allows you to swap and replace Laravel's classes with your own classes. And it can work within your application code as well. Maybe you want to swap and replace one of your own class with another implementation. Alright, so this is it for this episode. I hope you liked it. If you did, please hit the like button on the video to support the channel and subscribe to the channel if you haven't already done so. Until next time, happy coding.